Okay, welcome everybody to another event of IoT Developer Event Series. Today I have Kai Sieben with me, who will support me with the topic monitoring of Cumulocity IoT microservices. Kai will answering questions you have in the chat and will support me with timekeeping and such stuff. I will be the main speaker and guide you through the topic of monitoring Cumulocity microservices today. But before I get started, as always, and you might attended past events, I have some commercial and own interest. The first thing I want to promote is that we conduct an IoT hackathon this year on the International User Group from Software AG. If you haven't registered yet, if you know somebody who might be interested in joining a hackathon at the IoG in Budapest, we are very happy to welcome you on the hackathon. It's a one-day hackathon. It's a parallel event with the International User Group. We will be there with a lot of experts, myself, other people from professional services, a lot of people from R&D will be there. So really the experts will be attending. The topic is very open. We keep it to IoT, some around this Cumulocity IoT, of course. And a hackathon is typical for more technical people, developers, architects, mainly the people who are also attending this kind of events, of course. Yes, it's on 13 or mainly on 14th of June in 2023. That's in Budapest, I already said. So if you're interested, you can register on this link. As always, I will share the slides and the recording after this meeting, so you don't have to do a screenshot or everything. So this was commercial number one. Commercial number two, which I just published today, is if you are active in our developer community in IoT, you might have recognized that we have, I call it the IoT Community Awards. And for the first quarter, I just published the first top 10 people who attended, or the top 10 community champions who attended in Q1 with being active in the tech community, speaking in such kind of events, of course, providing tech articles in the tech community, and also publishing stuff open source at GitHub or anything else. And these all factors are calculated in so-called points. And these are the top 10 of this quarter one. So congratulations to all of the 10. What they get is mainly a very unique tech IoT community champion in the tech community. It's a badge. They can put it on your title, and people are aware of that you are one of the top community members. And of course, a small gift package will be sent and shipped to the people of the top 10. Community awards. That was commercial number two. And now I don't want to miss any minute anymore about talking about the monitoring of Cumulocity IoT microservices. The content is, I would say, pretty much a lot of stuff I want to show you today. The agenda is like following. I will start with what is microservice monitoring with Cumulocity IoT and why should I consider doing this? That's the first topic. The second topic is option number one, how you can do it, basic monitoring, basic microservice monitoring. Topic number three is how I can do this in a more advanced way. And of course, four, as always, we have a Q&A where you can ask your questions. Again, also as always, if you have any questions regarding the things I'm saying, I'm showing to you, if something is unclear, we have the Q&A session, but you can also use the chat and Kai will try to answer them right away. If not, I will read them out later on and then try to answer them myself. Okay, and then let's start it. What is microservice monitoring? In context of Cumulocity IoT, I have to say. Microservice monitoring is to find answers to one of the following or to multiple of the following questions. For example, the most urgent question, what is the current status of my microservices? Is it up and running? Is it down? How long is it down? Is it up, but has it maybe some issues, throwing some errors, or is there a request returning not 200 response codes, but maybe 400 or 500 response codes? Is that maybe the resource utilization very high? Maybe I have to correct my resource assignment of that microservice because the memory is already on top and I have to assign more memory or maybe make more CPU cores. Are there any times where I recognize peaks of usage? For example, in the morning, all my devices log in or people log into my tenant and I have a lot of peaks and usage of my microservice endpoint. And in around noon, everybody is not working or the devices are on sleep mode and not sending any data. So we can identify also peak and usage. Is there any metrics I can take care of that influences other microservices? For example, if I have a complex scenario and a process that one microservice is communicating with another microservices, and if one microservice is not behaving normal, how is the impact to that other microservice? Very normal question, what are the response times of my request? It's also correlated to the issues and lows and peaks, of course, but is the response time okay from the user perspective and from the device perspective, or take it up to 30 and 60 seconds and any more to receive a response from my microservice? And also to get more insights about the microservice, how often is an endpoint called? How many devices have been handled by my microservices? Is it just 5 devices, thousands of devices, to get an idea how many devices is handled by one instance? And so all these kind of questions you might want to find answers. And microservice monitoring is to provide you these answers with a specific tool set and with a specific process how to achieve that. And then you might ask the question, why should I do it? Maybe I have just one microservice and it's not critical, maybe a cleanup microservice or whatever. Why should I invest in a microservice monitoring? Why is it important for my IoT solution? It is because you want to make sure that if you have an IoT solution with devices, microservice, user interfaces, and users, of course, involved, that it is operating normal. You also want not act when something is happening, but you want to have some predictive metrics and tooling at hand that you want to avoid downtimes, especially when it comes to the resource usage and so on. Also, if you have an unexpected downtime, this is always involved with a lot of cost, because a lot of people maybe in the weekends have to, get active and maybe restarting, maybe doing fixes and all this kind of stuff. And this is all bound to cost. Also, if you have a IoT solution sold to your customers, maybe you have also SLAs in your contracts and you want to keep them. And if you want to keep them, you have to make sure that your IoT solution and the microservice are keeping this SLA, especially for the response times and up and down times, of course. Also, if you recognize you have some issues, it supports you in the root cause analysis. Maybe the high peak or the memory usage of the one microservices has an impact on the other microservice, and this helps you to find quickly an answer how you can improve it. And also, you don't want to pull the information out of the system anytime something is happening, but you will be or you want to be informed if something is going wrong. Yeah, so don't open a dashboard all the time and press F5, but you get an email maybe and informing you, hey, here's something wrong with your microservice. Also, if you have implemented microservice monitoring, it helps you to optimize your overall solution and to get insights into your solutions, especially like things which are implemented in the microservices. And to sum this up, why you should do this, it always increases the overall quality of the IoT solution. And I tried to find a definition of the microservice monitoring in context of Cumulocity, and I came up with this sentence: microservice monitoring means to collect and operating metrics of microservice over a period and visualize them in the dashboards and create alarms to be informed in case of issues. I do not include log aggregation here in this microservice monitoring topic. Some of you may be also saying, okay, log aggregation, and how I do make search in logs might be also part of the microservice monitoring. But today I only want to focus on the metrics of microservices, how I can collect them, how I can visualize them, and how I can work with the metrics. That's the what and why. Now I come to the first proposal, how you can implement microservice monitoring for Cumulocity IoT microservices. And I call this the basic microservice monitoring. What is it about? The basic microservice monitoring try to achieve to find answers to the questions to the what block I just showed you in a very simple and easy manner using the tooling you already have. In this case, we're using the capabilities of Cumulocity IoT. So the whole microservice monitoring can be implemented in Cumulocity IoT itself. So you don't need any additional tooling and additional systems or platforms to monitor your microservices. The architecture is like following. You have a tenant, and in your tenant, you have microservices. If you are familiar with microservices, there we have a different scope of microservice. We have microservice with a per tenant scope, so you have one instance per tenant. If you have a microservice with a multi-tenant scope, then you have an instance which is also subscribed to other tenants, but you only have one instance. Yeah? So for the per tenant, you only have, or you always have one instance per tenant where the microservice is subscribed. If you have a multi-tenant, then you have just one instance, but it is subscribed to multiple tenants and you have access to the tenant. This is from the monitoring perspective a different thing we have to consider because here you always have to monitor this instance, and in a per tenant scope, you always have to monitor all the microservices in all the tenants if you want to monitor them. If you have a customer tenant here, you need to monitor the microservice in that customer tenant. If you have an enterprise tenant or management tenant where you deployed your microservice and subscribe to, then you're using the management tenant or enterprise tenant to monitor the microservices. And the approach is pretty simple. In your microservices you are implementing, you're using the Cumulocity REST API and the domain model to publish metrics about your microservices and measurements, events, or you can even raise alarms directly from the microservices. For example, the CPU utilization, the memory consumption. If you have this metrics available in your microservices, you can create measurements for it in the REST API. And in Cumulocity itself, you have, as you know, dashboarding where you then have the measurements, events, and the alarms popping up in your customized dashboard you can create it. And we also have a role management and user management and can assign these dashboards only to administrative users to monitor the microservices. There's a very nice example, which is developed by a colleague of mine, Yishu, which is on GitHub. Again, we'll share the links later on, where she developed a so-called Hello World basic microservice monitoring in Python, where she is exactly that, doing what I just said, like having a microservice in Python, using the REST API, publishing metrics in Cumulocity, and then showing how you can use it in dashboards. Also, there's an article in the tech community by a step-by-step approach, how you can repeat that and follow the steps she's done with microservice here. As always, there are pros and cons about this concept of basic microservice monitoring. On the pro side, it's definitely you do not need any additional infrastructure or tooling. Also, the maintenance is done by the Cumulocity platform, of course. You take advantage of the existing functionality already. You can also take advantage of the integration by using a Cumulocity SDK, if an SDK for your programming language is available. So this is a very fast and easy way how you can implement a microservice monitoring. On the cons side, you can only, or it is very difficult to monitor microservices per tenant base, because if you have multiple customer tenants, and you have microservices with the per tenant isolation, then you have to have a user in the customer tenant and access to the tenant to fetch the matrix and to have actually dashboards there and to monitor within that tenant. Yeah. So for multi-tenant, this is not an issue, but for per tenant isolation, this might be very complicated and tricky because the metrics are only sent in that tenant where the microservice is deployed. It's also not very suitable if you have multiple microservices because the effort to implement that in every single microservice is very high because you have to repeat it all the time and you have to send the matrix and so on. You can do this, but then I would say it's not suitable. Also, the matrix you are collecting must be converted to the Cumulocity acceptable format. That's just a doing you need to do. And big downside on the cons side is if you have any issue with the Cumulocity infrastructure, for example, dashboarding or load balancers has some issues, if we are recognizing or we having some updates, then the whole microservice monitoring is not available to you and you do not have any independence from the Cumulocity platform, of course. So to sum this up, when should you use it? You should use it if you have one or a small number of microservices which are deployed mainly in one tenant, this multi-tenant scope. You should also use this if you're starting with a small solution and maybe the microservices are not solution or business critical. Like I said, a cleanup microservices, when it's down, okay, data is not cleaned up, but it's not critical for the overall solution. And you should also use this if third-party monitoring tools and additional infrastructure is no option for you at all. So you have to rely on the existing platform. Then, of course, you can use the basic microservice monitoring. Now I want to give you a demo about this. So let's start about this. And I always do this in the following way. First of all, I show you what needs to be done to prepare your microservice, then how to actually set it up. For the basic monitoring, I don't need to set up anything, but then I told in the third point how to visualize the data. So this is now how I to prepare my microservices. Again, this is a microservice written by Yishu, a colleague of mine, which is a Python microservice. And what she did is actually she wrote small microservices which uses some PSUtil functions to get the process information like CPU usage, memory usage, but also implemented some custom metrics like a task queue and also some endpoints where this task queue is then added or increased over time, and also having then an endpoint enabled. And the main part is to forward the data to Cumulocity. Yeah, so we have we getting the environment variables to get the credentials of the Cumulocity tenant. And initially we create a device, a microservice device, and then we just publish the metrics as measurements to that device. That's basically it. Very small microservices with logic to collect metrics using the REST API and publishing it to Cumulocity, and then we can use it. And now to the usage part. Share my screen in the browser. Here, as I said, we have a device called Basic Monitoring Microservice, which device has been created on initial startup. And now I have the measurements available here in my tenant. So if I click here, you see all these metrics of the microservice are now available as measurements, and I can use them and add them to my dashboards. Here I have added the CPU utilization. Here I have the task queue size, and then we can move it here a little bit around. This. Here I can just call the basic endpoint to increase the task count. And of course, you can use the smart rules, as I did here. So if a task exceeding a threshold, I think it was 5 here, then I create an alarm. Yeah, and now it is below 5 and the alarm is cleared. So we can use the existing tooling of Cumulocity to have dashboarding and alarming for your microservice model. You can see the request count, of course, the total request count and the number of threads, and you can add any other measurements you find useful to monitor your microservice, of course, in this kind of approach. So this was the first basic approach I wanted to show you. Now let's talk about a more advanced microservice monitoring approach, which is for most of, I would say, big IoT solution more feasible. Here we have a different approach and a different architecture. We are not using Cumulocity IoT built-in functionality like dashboarding. Here we make sure of third-party tooling, or we make use of third-party tooling like Prometheus and Grafana. I will explain shortly what these tools are. And set up an independent monitoring instance to monitor our microservices in not only one tenant, but in multiple tenants. Here we do not have the restriction on microservices that it is just in one tenant, and we do not have the restriction on the isolation level per tenant or multi-tenant, because each microservices we deploy on our platform, we expose in so-called matrix endpoint. And these matrix endpoints are pulled by a tool called Prometheus. It's a data scraper on a period of time, all the time collecting the data. And then we have a tool called Grafana, accessing the database of Prometheus and doing some dashboarding on top of the data which has been collected of our microservices. What is Prometheus and what is Grafana? Prometheus, as I said, is a data scraper. Yeah, it follows a pull approach. You configure it in a way you will see shortly that you configure endpoints and a time interval, how often the endpoints should be called. And the endpoints should have a default format containing all the metrics which should be pulled. I will show you shortly an example about it. It also contains a time series database where all the pulled data is stored. It also provides a query engine. So in Prometheus itself, you can query the data of that database already. Does not contain any visualization or advanced visualization. There we can have Grafana. It has a very simple UI to check the status of your configuration, do some configuration changes, but the main configuration is done in a YAML file. It is an open source tool, so it's free of charge. You can use it without having a license. And the main benefit of this Prometheus tool, it is very well established in that domain of application monitoring. And this means you have tons of Prometheus plugins available for all mentionable programming language and frameworks. So you don't have to take care that you have to implement anything on your own. For almost every programming language, you just search for your programming language and Prometheus, and you find a client or so-called plugin and can use it right away. What is Grafana? Grafana is a dashboarding tool which visualizes data. It also has some alerting capabilities. It also has a very, very big community and extensive plugins for several data sources, especially for Prometheus. So it's also very used very often in combination with Prometheus. It's also, again, open source, so free of charge. You don't have to pay for it. And it has pre-configured dashboards all right away. So for example, for Spring Boot Micrometer, you don't have to create your dashboards on yourself. There are already some templates and dashboards available. You just need to import them. You will see that later in the presentation. So what are the pros and cons of this approach? Some of them I already said. It supports both isolation levels. You don't have to take care about, oh, it's just a per tenant or is it a multi-tenant microservice. It also supports microservices which are subscribed to multiple tenants and assigned to multiple tenants. So you don't have to take care if it's just a customer tenant or you have hundreds of customer tenants and it's per tenant, so you doesn't matter. You can just add it to your Prometheus configuration. There are no additional license fees for software because it's open source. It has no impact of operational cost of Cumulocity IoT. If you use a basic approach, maybe this is also a downside. If you store metrics and you have an additional device, of course, this device and metrics is involving in your costs. So if you send a lot of microservice metrics data to the Cumulocity tenant, then of course it might be also charged to you. Here we have no impact on the operational cost of Cumulocity tenant because we do not store any additional data in the Cumulocity tenant. It allows dynamic monitoring and visualization, so we're very flexible in that regards. It's independent from the infrastructure. On the cons side, you need additional infrastructure. So you need at least an additional VM or any cloud system where you can set up your Prometheus and Grafana instance to monitor your microservices. It's also a little bit more complex to set up. In the basic monitoring, you don't have any setup step, but here you need to set up your components, of course, and you need to maintain these components, of course. Yeah. Here now to the when to use blocks. You should use the advanced microservice monitoring if you have multiple microservices in your IoT solution, especially also if they are communicating to each other. You should also use them if you have microservices per tenant scope. Also, of course, if you define your microservices are very critical for your IoT solution. If you want to collect monitoring and metrics externally and independently, it also might be a solution for you if you're saying, okay, I don't want to mix the IoT solution with the operation of the solution in one tenant. I don't want to mix that. Then you might also say, okay, I separate this for microservice monitoring and operating it. I have my own instance. And for the IoT solution, I just have my Cumulocity tenant. If you have the possibility and already have maybe a cloud contract with Azure, AWS, or whatever, and you have this infrastructure already available, then of course you can easily use this. And you can set up this infrastructure very easily. So these are the main benefits and when to use that of the advanced microservice monitoring. And here again, the demo in the following 3 steps. So first of all, how to prepare my microservices, how to set up the infrastructure, and then how do I do the monitoring with dashboarding. Let's start with the very simple one. Here I have a microservice template which is available in our GitHub account at Software AG, which is a template of collecting metrics or providing metrics. And this microservice has been developed in Spring Boot using the microservice SDK for Java. The main benefit of using the microservice SDK is it uses Spring Boot, and Spring Boot also uses some things like Spring Actuator. Show you. And the Spring Actuator has a lot of logic and components implemented. And also part of this actuator is can collect metrics and provide it as a Prometheus endpoint. So the only thing what you need to do is actually, if you're using the microservice SDK for Java, is that you just implement your microservices and the default metrics are already there, like the JVM metrics. But if you want to have custom metrics, then you need to implement your custom metrics. And here we have some plugin, which is also available per default, which is called here Micrometer. And here we can define a few things, which is now Prometheus specific, like a gauge, a timer, and so on. And here, for example, Kai implemented that to get all devices on a request. And here he had the timer and he's recording the time. How long does it take to get all the devices? And then recording it. And this is everything you need to do. And then it is automatically added to the Prometheus endpoint. And there are some other examples how you can do this. You can have a sample timer here, then you start the sample timer and stop it like this. Then you have your custom metrics. Now here we have custom metric device inventory requests. So the timer of the inventory request. So this is everything what you need to do. And once you have deployed your microservice, then you can go, I can go to my microservice. Let's see, endpoint. Which is now deployed in my tenant. Here I have a service, the microservices type template matrix, and here we have the Prometheus endpoint. Now I have to log in. It's working. I had some issues. Some caching issues here. Do this again. About the authentication, to have access to the Prometheus endpoint, you do not need any special role assigned in your Cumulocity tenant. You just need to authenticate with a valid user. This is also from a security perspective, very good, because if you use Prometheus, you should use a privileged user like an admin user or any other user which has also access to Cumulocity and to store data or manipulate data in Cumulocity. It's just the user do not have any access to the Cumulocity at all, but do have access to the Prometheus endpoint of your microservices to fetch the matrix you can see here. And if I just press F5, you can see the data is updated all the time. And all the JVM matrix of the Java virtual machine is out of the box there using Spring Boot and the microservice SDK. So I have to not write any single line of code to have this kind of information available. So the heap memory space, the garbage collector information, the CPU usage, everything is there, and I don't have to do anything. And also we have then the custom matrix, the process start time. Let's see if I can find them here. Device or inventory request seconds count, device or inventory request second sum. These are now the custom metrics we have added to the Prometheus endpoint as well. So we can also have them and use them in our dashboarding. So this is the, I would say, less effort way how you can implement it in your microservices using the microservice SDK, Spring Boot, and you don't have to do much, just focus on your custom metrics you want to monitor. But then, of course, you would not only have the possibility to use Java microservice or Spring Boot microservice, but you have also other microservices maybe written in C# or in Python. Here we have also implemented an example, which I have developed for the tech article. It's again a Python implementation, and what I'm doing is I'm using a plugin called Prometheus Client, which is available for Python. So what I need to do is I just install the Prometheus client from the dependencies, and I'm using this Prometheus client to define my custom metrics. Because when I have imported this to my Python, all the process and system metrics will be there out of the box, but I can also customize them and add additional metrics if I want to do so, which I did in my example here. Again, I have a hello world endpoint. Here I have a device counter to increase a custom counter, which I have created, which is the device counter. So counting up all the time if I call this endpoint, assuming that a device is created on this endpoint. Here it's just returning hello world. Then I added some more metrics for the system usage, like CPU usage and memory usage, the number of threads which I'm currently used by this process, And this is everything I need to do. I just need to set them, having a job running all the time or a thread running all the time through it, and then updating this matrix. And again, if I then open this in my tenant to actually see what's happening, back to the browser. So this is again my tenant. I have a microservice called Hello World Matrix. I have the Prometheus endpoint. I'm already authenticated here. And if I press F5, should see it is updating here. So all the matrix, like I missed to mention that I also implemented a Flask matrix about the request and so on, how many requests have been called. And here you see the CPU usage, the memory usage, and so on. So all the metrics are already here. And it's also the same for C#. So Python is just an example. For C#, there's also a client available, Prometheus client, and the approach is very similar. You import this client to your C# project. You have some out-of-the-box metrics already available, and you can add your custom matrix if you want to do so. So this is the prepare your microservice step. Now let's come to the next step. So our microservices are prepared. Microservices providing endpoints, Prometheus endpoint with all the metrics we are looking forward to monitor. And now we want to set up an infrastructure like Grafana and Prometheus. This can be done. I used here Docker as an example, and with a Docker Compose in a few steps only. The first step is that we need to create on our VM. So on the right side, I'm on my VM now, on the left side on my local computer. On the VM, I need a folder called Prometheus. In that Prometheus folder, I need a configuration file to configure Prometheus. Let's have a look on the Prometheus file. In the Prometheus file, you have the following information. So first of all, the scrape interval. So I defined every 5 seconds, I want to scrape my endpoints I have defined. Of course, I can go down to 1 second, or I can up to 30 seconds. It depends on your requirement and how often you want to scrape the information. And in the scrape config, I add all the microservices I want to monitor. So what I need to do is I need to provide credentials. Here I used, as I said, Cumulocity user without any access, but just having access to the Prometheus endpoint. The targets, which is my tenant URL, and the path, which is the service, template, matrix, Prometheus. Same as I just showed you in my browser. So this is my Java microservices. The second one is the Python microservice. So say again, I'm using basic auth, same user, same host, but the path is a different one. Now I use Hello World matrix and the Prometheus endpoint. And that's it. The basic configuration is just adding your endpoints with the targets, putting them on the VM. That's step 1. Step 2 is having a Docker Compose, which will also provide to you later on after this event, which is also very simple. The Docker Compose is just doing 2 things. It is spawning a Prometheus container and it's spawning a Grafana container using 2 volumes, a Grafana storage and a Prometheus data storage or volume. What I need to configure here is the ports I want to expose, of course. I keep it to the standard ports of Prometheus. I can add some volumes here. I just added my Prometheus configuration is mounted to my container, and I mounted the volume in the container. This is for Prometheus, everything I need. For Grafana, it's even more simpler. Again, the port configuration and the storage, which is, or the volume, which is mounted to the container. And of course, a lot of additional configuration. If you want to receive emails, you need to configure your SMTP server with SMTP users and so on. in the environment variables, and then you can also send emails out of Grafana or add additional data sources, maybe which are not located on the same computer. But this is everything you need. So if I then go to my machine, I can just go to the folder where I am. Here I have my Docker Compose file. In the Prometheus file, I have my Prometheus configuration file. And here just make Docker Compose up. And now on my VM, the service is up and running. Let's have a look. Yeah, now I can see I have a Grafana running with an exposed port of 3000. I have a Prometheus running with an exposed port of 1990. And now normally what you do is doing some firewall rules, like allowing incoming connection to this port, allow incoming connection to this port, and so on. So but I skip this for this moment. This is of course necessary. As the next step, we want to check if everything is up and running. So first thing I want to check if Prometheus is up and running. So Prometheus is running, and I also check the targets which are coming now from my configuration file. And here you can see I have now configured 2 endpoints, the Java Matrix microservice, current state is up. Last scrape was 4 seconds ago. And we have the Python microservice, also status up. Last scrape was also 2 seconds ago. So everything is like expected. Here we are the labels which have been provided by the matrix and by the configuration of our Prometheus YAML, of course. So from Prometheus wise, everything is up and running. And now we can go through step 3, using this data to create our own dashboards. So I go to Grafana. See, I already logged in. Normally, if you just set up Grafana, you need to log in with the user and password admin. Then you have to create your own password for the administrative user. And then you have to go to your data sources. Let's see where this is. Sources. Here we are. And then you click on Add Data Sources, Prometheus. And then here you just provide the Prometheus endpoint, which is locally, because Grafana is running on the same host of where Grafana is running. So we use the Prometheus, the Docker container name and the port, which is fine, save and test. And you see now I have 2 data sources, but I don't want to have that. So I delete this one, just want to have the one Prometheus data source, which I already use. So this was now to combine Prometheus, which is now collecting the data, storing the data in a time series database, and makes this available for my dashboarding. As a next step, I want to create a new dashboard. And here I have following ways how to do this. Of course, I can create a new dashboard from scratch, but this is, I would say, time consuming because every panel you have to create your own. Because of lack of time in this event, I will stick to importing dashboards. But also for the Java microservices, because we're using Micrometer, there are default dashboards available. Have a look on this, where we are. If I go to Grafana and search for Micrometer, you find a default dashboard with a container ID, with a dashboard ID 4701. And if I copy this ID like this and go back to my Grafana instance, I can say, okay, now I want to import Grafana dashboard, and I want to import it via grafana.com. Click on load. I can give it a name. Select the data source. Here I select Prometheus as a data source, which I have just configured shortly. And click on import. And now I have, without configuring anything, I have my pre-configured dashboard of my Java Spring Boot microservice. And as you can see, it's up since 6 days now. the percentage of heap used, non-heap used, and all the JVM data is out of the box available. The number of threads which are using, the CPU usage, the logs events, file description, all this kind of stuff. Yeah. And now I can, of course, because we have added some custom metrics like the response time of querying all devices, I can add them here as well if these are more important. Or I just create a different dashboard and add them to the dashboard where I just have a more like business dashboard, seeing what is the response times of creating devices or querying devices. So this is for the Java microservices. You don't have to do much. It's just, I would say, in a few minutes, you have set up your Prometheus and Grafana instance, and the dashboard comes out of the box. For the Python and C# microservice, it's a little bit different because we have custom metrics there, and there are no default dashboards available. Here we can create our own dashboards, and I have also done this. So maybe I just maybe I delete this one first. Dashboard. New, import one. And we have also the capabilities that you can export your dashboard anytime in a JSON format and then import it back, which I've done here. Here again, I have to provide a name, Prometheus endpoint, import it. And then I have a custom dashboard created for my Python microservice. And here I can a little bit dig into the panels you can see here. On the top, I have so-called rows, yeah, which I can define myself. And in that rows, I can have panels. For example, let's have a look on the status. On the status, I'm using a stat panel. And the stat panel is using now the following query. Yeah, you can use a builder. And in the builder, you can now search for all kind of available metrics in Prometheus, in the Prometheus data source. And here I have one which is called up. And up is not only available for my Python microservice, but also for my Java microservice. But here I just want to concentrate on the microservices, so I can also define filters. And here I want to filter that the app should be limited to the Hello World microservices. So this is the first thing, using stat. And then I can do some configuration. If you scroll down, you can do things like you can specify the unit, you can, which is here just a string. You can do some value mappings, which I did, because the up and down is basically a 0 and or 1. 0 for down and up, 1 for up. And what I did is I added a value mapping saying, okay, if the condition is 1, then it's up and then it's green. If it's 0, then it's down and then it's red. So this is one query you can do here. If you want to have more advanced queries like the system memory used, or for custom metrics, the device created, you can click in here. Then I have the matrix device created. Here I can of course specify the filter, but this metric is only provided by the Python microservice, so I do not specify any filter. And here I'm not now using a time series panel. And as you can see, there's a lot of other panels available here, which you can use. What I'm just showing you is to get started with dashboarding, yeah, like time series, stat pages. You can use gauges, histograms, a lot of other things you can use here in your dashboards, depends on your need. And here I'm now using the time series, which is the graph. And here again, I can define things like how I want to have it look like. What is the point size? Make this even bigger. What are the thresholds? If I want to define some thresholds, and then I can apply it, and then it's visualized in that way. And here I can just drag and drop this panel now to my dashboards in a specific role. So I can also move it to overview or memory. and then I can have my metrics. So this is the dashboarding. Again, this is just a starting point. You can do a lot more powerful things in dashboarding with Grafana. I just showed it. This is just a starting point. But this is more like the, okay, now I have a dashboard. I see what's going on with my microservices. So if it's going down, then this is going to change to down. The start time will be then changing and so on. But now you might asking, okay, but I want to be informed if something is happening. And this can also be done with Grafana. Here we have, saving the dashboard, the alerting capabilities on the left side. And here we can define so-called alert rules. I do not have created anyone here, but here I can say, okay, this is my status alert. And here again can say, okay, I want to monitor a builder, the up metrics. Yeah, if the up is changing, okay, now I can see these are the metrics, and then it should be is below 1. Yeah, so if the matrix is 1 is a normal condition, 0 is the condition when it should be firing. Preview. Okay, now it's normal. Then I can define some custom tags of alert rules. I have to specify some folders. That is not labels on. Just doing this now. Okay. And save. And now, after some time, it will evaluate the rules I just have configured, like up and down. And after some time, you will see the status here in the table for each microservices. For each microservice, I have configured this. And if this is now currently firing, or is it in normal again? Normal. Yeah, here we can see the status. So for one microservice, the Java microservice, it's normal. For the Python microservice, it's normal. And then I can also define some email endpoints. This is the default configuration. And then some templates I can add, where I add some graphs which might be relevant for the user. I will not do this in this event, but you can do this. And when then the microservice is down for any reason, for example, out of memory or whatever, is restarted, then you will receive an email. And that email then depends, of course, on the template you have configured. But normally you get an email, I will show you shortly, like this. And here we get an email like, this is a different microservices now, which is firing. The status is now down. I did not configure any template here. This is just a default template informing me that this information that the microservice is currently down, I have to act. And I also getting emails if it is resolved. So one is resolved, one is firing. If one microservice, for example, here, the other one instance, which is here the Python microservice, was resolved because it's up again. So I also getting emails about that. So this was basically it. And this is what I wanted to show you. Let's go back to the PowerPoint presentation. Too many windows open. Here we are. Now let's go to the Q&A. I have to open the mics if you haven't done this, Kai. See. accident. People allow mics. Do you have any questions? You can open your mic and now ask a question. I think there were already some questions in the chat.
Yeah, there was one question, but you perfectly answered, if it's possible to set alarms on the dashboards in Grafana.
Okay.
So those alarms that I meant, thank you for answering that. Those alarms, are those things I can send out as like text messages or whatnot also?
Yeah. Yeah, as I said, you can define templates. It can also contain the thing you see in the dashboards. It can also contain in the emails that you have a snapshot of some metrics which might be important for your microservice. And then an email template is sent out to you containing a graph of the memory consumption, CPU utilization, or the numbers of currently devices which has been created in the last 5 minutes, for example.
Thank you.
Both solution works on SIG-Edge as well. It depends. Of course, the basic one, of course, works on SIG-Edge as well, because the only thing what you need is the microservice feature on the SIG-Edge. This is a limitation, of course, because you want to monitor microservices, but everything else is then used in Cumulocity. And the advanced monitoring solution on SIG-Edge depends, because the SIG-Edge is somehow sometimes in an isolated environment. And you have to make sure that, of course, the Prometheus is also running in that isolated environment and have access to the microservice endpoints, which is Prometheus. And yes, then it's also working.
It's probably just gets a bit more complicated on the SIG-Edge. But in technically that works. You could even run, as Stefan showed, you could even run the Docker containers on the SIG-Edge itself. If you're aware of the Kubernetes limitations, monitor that yourself. And it's a bit more advanced, but technically it works. And of course, might be gone with an Edge upgrade. So it's better to definitely put that somewhere else, and some network limitations.
Another question: is it possible to create an API key in Cumulocity for M2M connections such as Prometheus, so that we don't have to create additional users? No, we don't have an API key concept in Cumulocity IoT, but we use OAuth 2, where we can have tokens. And these tokens then can be used to authenticate a specific user, especially. But of course, these tokens has some, they are valid until some time, and they are not valid, and you need to refresh that token and all this kind of stuff. And for Prometheus, I did not investigate so much if we can authenticate with a token, so I just use the basic auth. But I need to investigate if you can also use a token authentication based into Cumulocity. Then of course, it will also work with the token and not using key and password. But then we also have to take care about refreshing that token. Which is also not feasible, changing the configuration maybe all the time.
Is there a way to point those credentials to a secret or some other type of tool to keep so you're not hard coding the credentials in plain text like that?
I'm not so sure, but I can think about that. We can provide environment variables, and we can read from the Prometheus configuration file some environment variables, so we don't have to provide them in clear text in any files, and we just store them on the machine or on the container, and then it is then recognized from the environment variables. But I have to investigate in that. I did not made any research in that area. Maybe Kai, you have some experience?
No, but I had the same thought already as well, that it's not so nice to have it in a plain text file unless you really have control over who has access to the file.
Yeah, but again, this user he can actually basically do nothing. Yeah, it's just a user with no access right at all. He cannot even use to log in to Cumulocity. He can just call this one endpoint or this endpoint of the microservice, because here we have the microservice endpoint without having any restrictions, because it's not critical. Any other questions? Last chance. No. Then thank you again for participating in this event. Looking forward to see you one of the next